All right, so significance tests all begin with our hoe. Our null hypothesis. And the hoe is always against the ha. Our alternative hypothesis. So the null hypothesis is the claim that we want to disprove. So for example, let's say I'm just hanging outside the school, shooting the b-ball, minding my own business. And out of the bushes comes some, annoying guy, and he's like, "You suck at basketball, man." And I'm like, "No, I don't. I'm pretty good." And he's like, "Well, I can shoot better than you." And I'm like, "I don't think so, man. Look at you." And he's like, "Well, I can shoot 80% from the free throw line." And I said, "So what?" He's like, "That's pretty good," he said. I'm like, "Well, okay, fine. And I tell him, "All right, why don't you prove it?" And he says, "All right, I will." I'm like, "Okay, I'm going to give you 50 shots. You're going to shoot 50 shots from the free throw line, and we're going to see how many you'll make." So he shoots 50, all, with bad form, all weird looking, and he ends up making, some of them for some, weird reason. But it ends up only being 64% because he only makes 32 out of the 50, which is 0.64. But his claim is that his true proportion is 0.8. He's saying that he can shoot 80% from the free throw line. I'm saying he can't. So I'm saying that the true proportion is less than 0.8. The null hypothesis is what he's claiming. The alternative is what I'm claiming. It's basically the opposite or going against the null hypothesis. Now I'm like, okay, well, case proven. Seems like you're full of crap, man. You suck. Get out of here. And he's like, hold on, man. I'm having an off day, man. I've been hanging out in the bushes all day, and I got in a fight with a bunch of ninjas. I'm worn out. I'll come back another day and I'll prove it to you. And I'm like, yeah. And I don't really believe him, but I know that there's a possibility that he may be having an off day. So I'm wondering, if he actually does shoot 80% from the free throw line normally, what are the chances that he would have an off day and shoot 64%? So this is where we have to look at the logic involving like a simulation, a sampling distribution. So what we're going to do is look at a sampling distribution where the true mean of proportions is 0.8. And let's say we run a simulation of 400 sets of 50 shots. So all these little dots, pretend there's 400 of them. Each of these 400 dots, so 400 sets, are samples of 50 shots. So we run a simulation with a computer, using technology. And we want to find what are the odds of getting a sample proportion of 0.64 or less in this simulation. And what happens is that we end up only finding that 3 of them, that's percentage 3 right here, 3 out of the 400 have values of 0.64 or less. 3 out of 400, I believe, is like 3/4 of a percent, 0.00. So, in other words, the chances of him shooting 64% if the reality was that he was an 80% free throw shooter is 0.0075. That's less than 1%. So I'm just like, of course, see, he's lying. And so when we have a probability that's so low, we're going to intuitively be like, yeah, he's probably lying, because this is such a low value that it's going to be very, very unlikely to occur by chance. This is called our p-value. The p-value tells you what are the odds of getting a sample proportion as low or lower than 0.64 if the true proportion was 0.8. Now, you could always, again, argue, he could always argue, like, well, you know, it's possible, man, it's possible. Yeah, I know it's rare. I know it's less than 1%, but it's possible. And I'm like, yeah, I know it is possible. I mean, pigs can fly. I saw an episode on, The Simpsons. That's possible. I saw one episode 20 years ago. But it's super, 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 super unlikely. I'm not going to bet money on it. And then he walks away all grumpy. So that's the idea here. We want to basically use statistics to calculate probabilities so that we have strong enough evidence to either disprove or fail to disprove a claim. So there's two conclusions we can make. We can make a conclusion of rejecting HO. We say reject HO, reject the null hypothesis, or we say fail to reject HO. These are the possible conclusions. Now, the next question is, when do we decide to fail to reject, and when do we decide to reject? Like, when do we decide to go with this or this? Because we need to have a boundary value or a limit that if we were to get lower than that value, we're going to say we're going to reject HO. If we were to have a proportion higher than that value, we're going to fail to reject HO. So we need to have an alpha level. Going over here, alpha level. Or, well, we have a significance level. That's all. Your significance, well, let me put it over here. Significance level. And we usually will use alpha to denote our significance level. We want our p-value to be lower than our significance level in order to reject HO. If our p-value is not lower, then we fail to reject HO. So let me write this out over here. So how should I write this? So let's just do some of this. So we use our p-value to compare it to our significance level alpha. Depending on whether it's larger or smaller than our significance level, we're going to either reject HO or fail to reject HO. If our p-value is lower than our significance level, then we're going to reject HO. If our p-value is higher, we're going to fail to reject HO. I'm actually writing it like this because I don't recommend that you memorize this stuff. You want to connect ideas because it's really just logic. Because just think about this. This is our p-value. When it's really, really, really low, like if it was like 0.0000, if it was even lower than this, you're gonna be more inclined to say that the guy was, full of crap, that his free throw percentage is not really 0.8. But if the p-value was higher, if it was like 10%, then you're more inclined to be like, he could be telling the truth. So use the logic. So if the p-value is lower than our significance level, we reject HO. If it is higher, then we fail to reject HO. The significance levels will vary depending on the situation. The typical significance value or the alpha value will be 0.05, 5%. The lower it is, the more serious situation in like medical like cases, or in cases of like, life and death, it'll be, maybe 0.01. If we're talking about business and like just, money, stuff like that, it's probably going to be higher. It just depends on the context of the problem. If the problem doesn't say, then just go with 0.05. Now, when we have a conclusion, we have to be aware that we could have the wrong conclusion. So let's say that the reality, is one of two possibilities. The reality could be that HO is true, or that HO is not true, or the alternative is true. So we could say HO true, HA true. Now, there are two conclusions. Either we reject HO, or we fail to reject HO. So we reject our HO. Gotta get down low. Or we fail to reject HO. There's two ways to get the correct conclusion. We could have that HO is true, and if we fail to reject HO, this is good. This is say yeah. We get the right conclusion. We're good. Or if the reality is that HA is true, or HA is true, then we want to reject HO. And yeah. So we have two ways to get the truth. Whoop. However, there are two ways to get the wrong answer. If we reject HO when HO is true, we made a type 1 error. And then if we reject HO, if we fail to reject HO when the alternative is true, then we made a type 2 error. We don't want to make any errors, so we have to always be aware of that. All right, I'll see you guys in the next video.